2-1, identifying functions. And this one's also pretty simple. I would say even simpler than that of first unit. Also, I sent out a form to see if we might switch the time of the class. So complete that as soon as you can as well. So identifying functions. First of all, what is a function? Function is anything that can graph on a that also passes the vertical line test. So let's write out a function. For example, you might have, let me change this to equals x plus 1. This is the function. You might also see y written as f of x. This is the same thing as y. And as you may know, on the Cartesian plane, or the coordinate graph, this is the y-axis, and this is the x-axis. We can graph functions with their rules, which I wrote out. So y would be the rule yes. So rule in that. Okay, let's talk about the vertical line test. Vertical line test is basically a test that determines whether or not a graph is a function. So what this basically says is that at any point on the line, if you put a vertical line through it, the line is only going to intercept the function at one point. For example, if our function for a line like that, it only touches here. So that means this line is a function. However, if, for example, our function looked like this, if we put a vertical line through here, it touches here, here, and here. And the vertical line test states that it can only touch once to be a function. And since it touches 3 times, it's not a function. If it looks like this, do the vertical line test. Is this a function? If you answered, yes, it is a function, you'd be correct. At any point, if you put a straight vertical line, that's pretty straight, it only touches at one point. Anywhere, it only touches one point. Even though it isn't a straight line, it's still a function. Okay, this one. This is a function. If you answered, no it is not, you'd be correct. If you put a line through here, it'll touch in 3 spots. If we put it here, it'll touch in 3 spots. If we do it here, it'll touch in 2 spots. And that's not. So, but you might say, what about here? It only touches 1 spot. Actually, the line a bit straighter. But what the vertical line test states is that anywhere, every single place on the graph should only intercept 1. So even though it only intercepts once here, it intercepts more than once on other parts of the graph of the equation. So that's not. So this particular equation is not a function. So now let's talk about different types of functions. So here we have 5 main functions that you should know. And these are the linear function, quadratic function, so x squared, basically, and then the other quadratic function, x cubed, and then a square root functions, and then also absolute value functions. We won't go into inverse functions, which you will learn, and this is also part of Algebra 1, except it's not as, I guess, I didn't add this to the sort of curriculum that I have, so, I mean, you'll learn it at one point. Let's go over linear functions. So, if you just look at its name, you can kind of guess what it is. A linear function has line, it's really close to line, so that a linear function is just any function that's a line, basically. So this is a function, a linear function. Now this is a linear function. The linear function. This is not a linear function because it doesn't pass the vertical line test, but it is a line. This, slight upward, extremely slight upward. Those are all linear functions. And the rule of linear functions, which we'll learn tomorrow, looks somewhat like this. Mx plus. This is what a linear function will look like. An example of this could be y equals 2x plus 4. Those are linear functions. You should take notes of what a linear function looks like. A linear function is m, this is a negative m, but we won't as much. So all you really need to know is a line, a straight line, is a linear function. This is not a linear function, it is not a function because it doesn't pass the vertical line test, so keep that in your notes as well. And this is also a linear function, so just write that in your notes as well. Yeah, that's it for linear function, and let's go on to quadratic functions where it's x cubed. So in a x squared equation, it looks like this. This is a positive m, and this for a negative m. Something like this, a u. Actually, like this, sort of. This is an x squared function, and it will look something like y equals m x squared, maybe, you know, some other thing plus x, and then so an example of a x squared equation could look like y equals 3x squared x plus 4. This could be a x squared function, and since the first number, the m, I guess, in this number in x squared is positive, it will look like this. Otherwise, it will look like this. But all you need to know is if it's x squared function, it will look like u's. Like that, or like that. Extremely steep, or not steep, don't, like steep, extremely flat, or what? It can look like this, or like this. So just keep in mind, u's are x squared. Next one we're going to go over are x cubed. They're basically like x squared functions when you write them out, except there's also an x cubed term inside the equation. And x cubed functions look like this. Write that in your notes. X cubed looks a bit like a noodle that turns and stuff. So it could look like this, depending on how steep it is. Yeah, so just remember that if it's an x cubed function, it looks like an s in both ways. So this is an x cubed, and this is a negative something x cubed, and we will not learn this, but just keep in mind that sort of s-shaped. So this is an x cubed function. Next thing we're going to learn about is square roots. Square root functions look like this. They stay on this side of the graph. You will never get a square root like the other way. You'll never. Keep in mind, if you really think about it, you might have seen this already, but a square root function is basically like half of a x squared function, except turned a bit. X squared functions look like this, and a square root function is. And we will learn about what x squared and the square root of x have in common. They're sort of the same. Why they're sort of the same in like chapter 3 or 4 or something. So keep in mind that when you have square root functions, they look like this. Depending on what. But just remember that a slight curve and then look straight, that's a square root function. This type of function actually looks like this. They look like these, and these are called absolute value. Absolute value is basically how close that number is to 0. For example, the absolute value of negative 5 is 5, because it's 5 spaces away from 0. Is the absolute value of 5. Whoops. It's also 5. So you can really just think of it as that number, but you take away its negative sign if it has one. Just positive 5, it doesn't have a negative sign, so you just keep it as 5. And these functions look like v's. And they can look like v's in both directions. Like that. And keep in mind that these functions can intercept the x-axis at any point. For example, you might have a parabola of x squared that looks like this. Yes. You don't know until you look at the function rule. Now let's just talk about some rules about functions. These functions that we learned about. This isn't part of the homework or anything. You can skip this if you'd like, but this is just a few things I want to talk about functions, so what they can, what they can't do. First of all, let's talk about linear function. linear functions, they include all of the y-axis and all of the x-axis. This side of the positive y's and the negative y's. You can have the negative x's and the positive x's. Linear functions, you can have all of them, no matter where it is, whatever. It looks like, I mean, you can't really have y, but linear functions, it doesn't have like a true limit. Squared functions, however, it looks like this. It can have all the x-axis. It can be any x, but it can't be negative y's. So if the function looks like this, without just the x term, it will look somewhat like this. So actually, exactly 0, and it goes back up right after it touches 0. In this case, you cannot have a negative. There's no way the graph ever touches negative y. So that means y can never be negative 1 in this graph. The graph is opposite. If m was negative, then it would look like y would never be positive. So just keep that in mind. However, if you have that middle x term, your graph can dip like this. But in this case, where there is no middle, just x term, and it's x squared and just b, then your graph should never touch the x-axis in two different places. So if it's mx squared plus b, then it can never be, it can only be 1/2 of y, the y-axis. So only the positive or only the negative. The next thing we're going to talk about equation where x equals x cubed. Not sure about this, not like extremely sure, but you really just look on it. It can be all y and all x's. However, it should only stay in 3 quadrants. But if it's just y cubed, I don't know, that's it or something, it should touch the origin. So 0, 0. Wait, 0. The origin. And it should only be in 2 quadrants, but if it has d term, it can move up and down. It's also somewhat like the linear function. It can have all y's, all x's, and yeah, as long as x and y are real, you can have this square root. As I said, square root functions, they can only be positive. You can never have a negative square root. For example, the negative square root of 1 is not a real number. So we cannot have that on our graph. Which means square root numbers, the square root functions look like this. And this equation might look like y equals the square root of x. However, if it is the negative root, then this function would look like this. Keep in mind that this function never touches x is negative, so x is never negative in this type of function. Absolute value. Absolute value is also like quadratic equations where x is squared. If it's on one side, if if it's just y equals the absolute value of x, whatever, x plus b, I guess m plus b, without the b actually, just x plus m, then it can only be positive or only like this. It should touch 0 and then jump straight back up. It should never dip under if there is no b term outside the absolute value signs. Either only positive or only negative if it doesn't have a b term, just like quadratic where x is squared. Of course, this isn't. We're not going to go over this because this isn't really something that I feel like I spend that much time on. So just remember how each function looks, and that's all you really need to know. For the homework, also you need to know what is a function, what isn't a function, and how to determine whether or not something is a function. And that's all you need to know for today's homework.